Okay, so get ready to put your math skills to work to solve this interesting little math word problem. Matter of fact, let me go ahead and read the problem. It is the following. The digits in a price of a pen were mistakenly reversed. Now, the wrong price makes the cost of this pen 27 cents more. If the sum of the digits was 15, what was the correct price of the pen? Okay, so that is the question. Feel free to use a calculator, but if you can figure this out, go ahead and put your answer into the comment section. I'll show you the correct answer in just 1 second. Then, of course, we'll walk through exactly how to solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And if you need help learning math, well, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoyed this content, make sure to like and subscribe, as that definitely helps me out. Okay, so let me go ahead and read this problem one more time before I show you the answer. It could be a little bit confusing, but let's see if we can kind of clear up any confusion right now. Okay, so the digits were mistakenly reversed in the price of this pen. So for example, if the pen cost 41, actually cost 41 cents, if that was the correct price, well then if you reverse the digits, that price is going to be what? 14, right? So that's what it means to reverse the digits, or what happened here. All right, so the digits of this price of this pen were mistakenly reversed, making the wrong price cost 27 cents more than the actual correct price. Now, if the sum of the digits was 15, what was the correct price of the pen? So we're going to have to do a little bit of work to figure this out, but if you got the right answer, well, you would have discovered that the correct price of the pen is the following: 69 cents. Okay, so how did you do? Well, if you got this right, very, very good. Matter of fact, in my book, you're going to get a nice little happy face and A plus, a 100%, and multiple stars. So you can tell your friends and family that indeed you are a certified professional in solving basic math word problems. Well, in actuality, this particular problem, I'm going to solve it using algebra, and we're going to have to do a little bit of algebraic work to figure this out. Now, notice that I didn't say solve the algebra word problem, because when people hear the word algebra, typically they'll be like, algebra, I don't want to do algebra, it makes my hair stand up. So if you figure this problem out, if you got the solution using your own creative math techniques or whatever the case is, that is fantastic. But remember, algebra is a math tool. It just makes things much easier. So if you are afraid of algebra, hopefully as I go through the solution, you'll be like, you know what, that's not a bad way to solve this problem. And if you're totally confused, well, let's go ahead and get into the solution right now so you can see how we got the correct answer. All right, now some of you might be saying, well, is this the right answer? I'll show you at the end of this video. We'll kind of double check this solution to make sure, or to kind of verify, yes, indeed, it is the correct answer. But let's go ahead and get into the problem right now. Okay, so first things first, we are dealing with a math word problem. Now, whether it's algebra, basic math, trigonometry, it doesn't make a difference. Or even if it's just not even a math problem, any problem, okay, in life, you want to make sure you fully understand what's going on before you start to, try to solve the problem. You can't solve anything unless you fully understand the details and you understand the question. So I always like to use the rule of three. Read the problem at least 3 times and make sure you understand the question. Now, of course, we need to understand what the word digits mean, and I kind of broke that down, but we're going to have to take a closer look at digits here in a second, digits of a number. So the price here was mistakenly reversed of this little pin, and it's making the actual wrong price cost 27 cents more. Now we're told here that the sum of the digits was 15. So what was the correct price? So what can we do here? Well, we're going to have to understand the price of an item and the respective digits of that price. So let's do a quick review, and then we can kind of build a nice variable expression to represent the correct price and the wrong price. And from these expressions, we can use the information in the problem to build an equation and then to solve for those respective variables. Now, in this particular case, I'm actually going to be building a system of linear equations. So again, I never like to tell people, hey, do this to solve this problem because you can come up with all sorts of creative ways. Typically, you're going to have to kind of generally follow what how I'm solving the problem. But some of you could have figured out another original, approach that works. As long as you can explain your solution, I think that's the real litmus test. If you figure this problem out using trial and error or something, as long as you can explain it, I think that makes it a valid and an effective solution. But let's go ahead and get into this right now. And let's review the price of an item. So let's take something like 25 cents. Okay, so 25 cents. Let's just take a look at the units here. So we have the tens unit, right? So this is the first number here. And then we have the ones or the units digit, right? So these are the digits, excuse me, of a price, something like maybe cost 25 cents. Now, of course, in these day and age, not many things cost 25 cents because of inflation, but that is a whole different story. But anyways, so if we have an item, okay, that costs 25 cents, the first digit here, okay, is the tens digit, and the second digit is the ones digit, okay, or the units digit. Now, to really kind of build this price out, or to have a model of this price, we need to kind of remember how tens, place value kind of works, right? So the tens units means what? Well, you're going to take this number, which is 2, and you're going to multiply it by 10. So that would be what? 2 times 10 or 20. And then when you would add whatever your unit's digit is, so in this case it's 5, so 20 plus 5 is of course 25. So this is just a kind of quick review on digits and place value, all this kind of stuff that we learned way back in the second and third grade, or maybe the first grade, who knows, but it was a long time ago for most of us. All right, now what I'm going to do here is I'm going to use two variables to represent the digits of our price. Okay, so we have a lovely pen over here, and it has some sort of price in cents. So we're dealing with cents. We're talking about, let's kind of go back up here in the problem. So we're talking about 27 cents. So we're going to build the price of this pen in terms of cents. So there'll be a 10 and ones units, and we're going to establish some variables here. So let's let the variable t represent the tens digit or for a particular price, and let's let the variable u represent the digit for our ones or our units digit. So we could build now a model of some pricing for our pen. Okay, so hopefully that makes sense. Now let's go ahead and take a look at our models. All right, so we're going to let 10 equal the tens digits of the correct price, and we'll let u equal the units digit of the correct price. So let's go ahead and start with the correct price in mind, because once we have this, then we can kind of reverse the correct price, right, to have the wrong price, and then we can kind of do some things from here. But let's go ahead and take a look at some algebraic expressions, knowing that this variable t represents the tens digit and of the correct price, namely, okay, not the wrong price, and then u is the units digit of the correct price. Okay, so from that, we can build out the correct price. So the correct price is going to be 10 times t, which is the tens digit, excuse me, plus u, which is the ones or units digit, right? So this is a representation of the correct price, okay? Now, the wrong price is what? Well, the digits were reversed. So in our 25-cent example here, right, the units digit becomes the tens digit, right? So this is going to go over here and be multiplied by 10, and then the 2, the tens digit, becomes the units digit. So here, if we have the wrong price, we're going to flip the digits, but algebraically, that means our unit number is going to be multiplied by 10, which of course is wrong, and then our tens value is over here floating as the units or ones digit. So this part of the problem you kind of really have to think about. Now again, if you approach this in a different manner, that is fantastic. But algebra is it's an awesome tool. I mean, this is why it's taught, right? It solves problems for unknown values. But what you want to do is look for some sort of variable or either using one variable or multiple variables, but you're looking to build algebraic or variable expressions that represent something. So in this particular problem, what we are concerned with is the correct price and the wrong price. So we need some sort of representation of this, and now we have it. Okay, so this is going to be our variable expression for the correct price, and now we have a variable expression for the wrong price. And with this in mind, we can actually build ourselves some equations. Now, before we show you these equations, let's just talk a little bit more about some algebra, which of course I know is all of yours. It's your the thing that you just get up in the morning with, you get your cup of coffee, like, boy, I can't wait to do a lot of algebra today. Well, that is kind of my life because I do enjoy mathematics. But let's just take a look at the scenario right now. So we have two variable expressions, but we have two variables. We have t and u. So what is this telling us? Well, hopefully it's saying to you, well, if you have two variables that you're looking to solve for, we're going to need two equations. We're going to have to build two equations. And when you have two equations with two variables, we're talking about a two variable linear system of equations. So a lot of you are like, oh my goodness, Mr. YouTube Math Man, you got me so confused. Well, this is probably like first year algebra stuff. So because we have two variables, now you want to be thinking about the rest of the information in the problem to build out two separate equations. Okay, so this is kind of what I'm getting at. And if you were kind of struggling to, find the correct path to solve this problem, you should maybe pause the video and see if you can build these equations. Of course, I'm going to show them to you right now, because if you can build these equations and then solve the system, well, you can, obviously, solve the problem. Okay, so let's go ahead and do that right now. Okay, so we're going to have to go back to the rest of the information in the problem because obviously there's a lot of clues here. So the first piece that we want to look at is that the wrong price costs 27 cents more than the correct price. All right, so this right here we can build an equation with. And then the second part of this problem is the sum of the digits was 15. And this right here is going to allow us to build another equation. So we're going to have two separate equations, two variables, and then of course we'll have everything we need to solve this system and figure the problem out. Okay, so let's go ahead and do this right now. And we'll start with this first part. The wrong price costs 27 cents more. Okay, so if the wrong price costs 27 cents more than the correct price, well, what does that mean? Well, if we have the correct price and we add 27 cents to it, that indeed is going to be equal to our wrong price. Okay, now we have variable expressions for these, right? So we're going to plug these in, and here is our wrong price. Remember, our units and our tens digits are flipped. So 10u plus t is a variable representation of our wrong price. Now our correct price is this, right? 10t plus u, but plus 27, right, is going to be equal to the wrong price. So make sure you understand this setup, and when you are doing these problems on your own, don't rush through these equation setups. Like double, triple check your logic because it's easy to make a mistake. Oftentimes what will happen is that people will have the correct price over here and then like the wrong price plus 27. This is a common mistake. So always, and not for this specific problem, but in general, okay, when you're making, you're kind of building an equation for two different relationships, you have to really double check that you have this right. So just kind of build yourself a simple little, equation like this using words, excuse me, versus variable expressions, and then kind of go from there. All right, so sorry to stumble and bumble on my words here, but I am trying to explain a lot in this one video. All right, so now this is one equation. Of course, we could clean this up, but we'll get back to that in a second. But let's go ahead and figure out this second equation. All right, so the second equation is the sum of the digits was 15. Okay, so this is, it could be a little bit confusing, but now that we understand digits, if we have 25, okay, let's go back to our 25 cents item price. What is the sum of the digits? Well, it's going to be 2 plus 5, right? 2 plus 5, of course, is 7. Doesn't make a difference if we add the 2, the tens, and then the units, or the units and the tens, we're still going to get the right answer. So the sum of the digits here, you might be thinking to yourself, well, doesn't it make a difference if we're using the right price or the wrong price? Nope, it does not, because if you flip the digits, you still have the same numbers. So the sum of the digits is 15. So you can either use t plus u is equal to 15, or u plus t is equal to 15. These are equivalent equations. Okay, so now we have these two equations. We have this equation and this equation, and we have enough information now to build ourselves a system. So let's go ahead and clean up this first equation right here, as it does have a lot of work. So hopefully you can kind of understand the algebra. What I'm going to do is move all these variables. I have u and t and u over here, then we have a number. So in terms of a system, what we want to do is get everything in this format. We want to get our variables kind of lined up in a column manner, whether it's going to be u and t or t and u, equal to a number. Okay, so that's what I want. And so over here, I'm going to leave this 27 on the right-hand side of the equation, and I'm just going to simply pick up and move this entire expression to the left-hand side by subtracting both sides of this expression times 10t plus u. Now, I'm doing it this way because oftentimes you might see a solution to a problem, an algebra problem, in a textbook, and sometimes you may not understand the steps. Now, if I was actually kind of teaching this in a class, I would say, okay, what you want to do is subtract 10t from both sides of the equation, then subtract u from both sides of the equation. But you can also algebraically use this notation right here. So that's what we're doing. And so let's go ahead and clean this up. So we have 10u plus t minus 10t plus u is equal to 27. So now we have the lovely distributive property here. So we're going to multiply this negative times this 10t and this negative times this u. So I have 10u plus a positive t minus 10t minus u. And now when we combine like terms, what are we going to get? Well, right here, we're going to get a negative t, right? 1t minus 10t is going to be a negative 9t, so I'll write that here, and then a positive 10u minus this u is going to give us a positive 9u is equal to 27. Okay, so lots of work here, but hopefully nothing too difficult. Now at this stage, I can divide everything by 9, or you could factor out a 9 from the u minus t is equal to 27, and then you can divide both sides of the equation by 9. Either way, you're going to end up with u minus t is equal to 3. Okay, so a lot of work to get down to this point, but this is a nice simple equation, okay? But we need the other equation, which was the sum of the digits part. So we have this equation right here as something we can form a system with. And then we have the sum of the digits equation right here. And now we have a lovely, simple two-variable linear system that you can use a couple different techniques to solve with. So you want to be thinking about the substitution and or elimination linear combination methods to solve for u and t. Okay, so let's go ahead and take the next step, which of course is having you quickly subscribe to my YouTube channel. Don't you just love how I kind of sneak that in? A lot of you are saying, this guy's probably just can't wait to say, hey, subscribe, subscribe, subscribe. Hey, listen, I know a lot of people with YouTube channels are, may ask you to subscribe. That's because it's very important. For someone who's been on YouTube for well over 10 years and have actually well over 2,500 plus videos, I can tell you it is important to have people show support. And the best way to show support is by subscribing, because you can't grow your channel. And in my case, I can't reach as many people as I want to reach and help in mathematics unless, the algorithm says, hey, you know what, people don't mind listening to this guy. So I need you to help me out by hitting that subscribe button. And if you're going to do that, hit that notification bell as well. Now, if you're new to my channel, first of all, I want to say thank you so much for checking in. But on my channel, what I focus on is teaching math at the range from basic math to advanced math, kind of up to somewhat of a calculus, but pretty much everything in between. So if you're at that level of math, you definitely want to follow my work, because I'm giving you my best advice, all my lessons learned from decades and decades of teaching math, studying math, and hopefully I'm trying to make your math life easier. Okay, so let's get back to this problem, because we do have a little bit of work to do. So we have a lovely two-variable linear system, right? So we need to solve for u and t, And once we have U and T, we basically have the digits, right? So again, if we have 25 cents, this one right here, this is our tens unit, our tens digit, excuse me, and U represents our ones or our units digit. So if we know what U and T are, we can actually build the correct price. Okay, so what are some good techniques to solve this equation? Well, right off the bat, you can either use substitution or linear combination. Now, if you don't know how to solve systems and you're like, hey, Mr. YouTube Math Man, this is where I'm struggling with. I'm really sad. I can't solve systems. Well, don't panic. What you want to do is check out my algebra courses. I'm going to leave links to all those in the description. And if you're not taking algebra and if you want to learn this stuff, check out my Math Skills Rebuilder course. You'll find a link to that in the description as well. But hopefully you're going to understand the next series of steps that we're going to go through to solve this system. Okay, so what we want to do here is eliminate one of the variables. Okay, so we have two variables and we want to eliminate one of the variables, and the easiest way to do this is to add down in a column manner. You're allowed to do that. This is called a linear combination. You see, I can make a new equation, okay, from these two equations. So you can add these together or kind of smash them together like peanut butter and jelly. But the whole idea here is to get rid of one variable, to eliminate one variable. And either the substitution method or linear combination or elimination method still have the same goal. What you're trying to do is construct one equation with one variable. See, here I have u and t. I want one equation with one variable. And if I add down, I'm going to get 1u plus 1u is what? That's 2u. Negative t plus t, the t's go away. So that's what I want. And then, of course, 3 plus 15 is 18. And now I have a lovely equation with just one variable, u. So I can solve for u here pretty simply by just dividing both sides of the equation by 2. Okay, so now I'm going to get u is equal to 9. All right, so now once you have one of these variables, it's very easy to solve for the other variable. So you can either plug that value in for u into the first equation or second equation, doesn't make a difference. I am going to go ahead and use that second equation. So the second equation is u plus t is equal to 15. We know what u is equal to, it's 9. So we'll replace this u with 9, so 9 plus t is equal to 15. So to solve for t, all we have to do is subtract 9 from both sides of the equation, and we get t is equal to 6. All right, so t is equal to 6, and u is equal to 9. So remember, we're going to write a price, though, as t and u, right? So the tens and the units or the ones digit. Okay, so we have to be very careful here. So let's go build the actual correct price. Okay, so we have to go back to the setup in this problem. So remember, so here's our answer, right? So u is equal to 9 and t is equal to 6. So the correct price is 10t plus u. Okay, 10t plus u. So let's not confuse this. T is 6. So we're going to plug in 6 for t. Okay, so 10 times 6 plus u. This is our ones, which of course is just 9. So 10 times 6 is 60. 60 plus 9 is 69. All right, now based upon that, what would be the wrong price? Well, the wrong price is 10u, right? So we had the digits reversed. So our u here again was 9. Okay, so let's plug this in and just build the wrong price out. So 10 times 9 is 90 plus the tens, which is 6, is 96. So this is the wrong price. Now let's see if this makes sense according to the problem. So the problem says the correct price, which is 69, the digits were reversed. So if I reverse the digits of 69, I'm going to end up with 9 and 6. So that makes sense, okay? Now the sum of the digits is also 15. Well, let's see if that works. So 6 and 9, well, that's 15, and 9 and 6, that's 15. That works as well. And it said that the wrong price is 27 cents more expensive than the original correct price. So if the original correct price is 69 cents and it's 27 cents more expensive, well, 69 plus 27 is 96. So this whole thing works out. Okay, so hopefully you found this problem interesting. Okay, that's the whole point of me doing these videos, is to try to get you interested in learning mathematics. Now, if you stuck with me this whole time, well, first of all, I'm going to say thank you so much. Second of all, I'm hoping that I'm delivering some good value to you, right? That you're learning something. And I take things nice and slow because when you try to learn math too fast, this is how this happens. Okay. You can't learn these concepts one, two, three. And typically people are like, you know what? I don't really have the time, Mr. YouTube Math Man. I just got to take this test and I got to get like an A plus on this test. So why don't you teach me all of this in like 3 minutes flat? Well, if your attitude is you want to learn things quick and fast, well, there are tutorials and you can get some basic sense of a problem and some concepts. I'm not saying you can't, but you're never truly going to master anything. It just takes time because you got to have some level of patience and you got to do the work. You got to get great instruction and you got to practice, practice, practice. Okay, so again, if you need help with any of these topics, check out my respective math courses. Again, I probably would direct you to at least my Algebra 1 or Algebra 2 math courses. You can find links to all these things in the description. But with that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.